circular functions on the CAS. So we'll go through a bit of solving, sketching, and application questions here, as well as a cheeky little bit of defining functions and variables. You'll notice that I've typed out some of the questions in advance. I'll show you where some of the buttons are that are useful on your CAS. Make sure you're set to radians as well. You should be set to radians for this unit. Sometimes in year 11 they do degrees in the textbook, but generally year 12 is in radians, and you can convert between the two fairly quickly. But yeah, let's get into it. So here I've typed out my solve. I've typed out my equation as I can see it, which is perfect. And if I press enter, I get a bit of a strange result. So these N2 or N1 values, this is actually the general solution for these circular functions. So when N2 is 0, 1, 2, 3, we would get different solutions for these values, for these X values. So if I copy this down and use my control equals, I can get this vertical line, and I'm going to do negative pi, and it's included, so square brackets is an included value, so x is greater than or equal to, and then pi here. And when I press enter this time, it gives me the exact solutions between negative pi and pi. Again, it's a bit hard to see all of those, so you can go up and press the left and right arrows to navigate through those. You can see them all there. But that, by adding the domain, gives us the exact values for that question. And you can see a similar thing for our second question here. So I don't need to rearrange for it to be 0 equals or anything like that. I can just type it in as I can see. I've set my domain and we get our exact values there. One thing I did do is change my theta to x. It's just a bit easier to type it in, so that's what I'd go for. And last but not least, we have a tangent function here, tan of 2x equals root 3 between negative pi and pi. Tan operates a bit differently to sine and cos, so again, you might get a fewer results when you're doing tan, but it just depends on the question and how much our dilation has impacted the equation. But again, we've got our values. We could plot those. We might even convert them to have a common denominator, as that can really assist us when sketching. But you can always, of course, copy those values down, manipulate them in any way you would like in the calculator page. One point to make here is these are all exact values. We are not getting decimals, and you'll notice a bit of a problem when we're sketching on the graph page in just a moment. So here we go. Our first sketch is f of x equals 2 sine of x over 2. So I can just start typing that in here. Of course, our trig button will give us sine, cos, and tan. We've got control divide by to get a fraction. I can just type that in. It does give us our correct graph. Let's just do a little bit of manipulation here. So I'm going to change this to -1. And I can actually type in pi values on here. So I could just do 4 and then pi. And that's actually the end of our graph there. We can see that there. But you'll notice that it does continue on. So if I press tab, go back to our original equation, I can add in our domain of 0. And 4 pi. And you can see now that the graph ends at those points. So to find some information here, we can use menu, trace. 0 will give us our y-intercept. We can kind of see that that's 0, 0. If I wanted to find these x-intercepts, it's menu, analyze, 0. Menu, analyze, 0. So this is a good little error that's come up. This is effectively saying 0.00, well, there's 11 zeros and then 582. So it's a really, really, really small value. Basically, the CAS has rounded our x-intercept of 12.6, and it means that we're not actually getting a y value of exactly 0. But in your interpretation, remember that this is actually exactly 0. So if we were sketching this in a test or an exam, we'd probably want these as exact values. Could be decimals as well. But if I wanted to find this as an exact value, I need to do the calculator page, or I can do menu, trace. And if I type in 4 and then pi, it'll actually, oh no, not I, pi, and it jumps straight to that point. So it's actually doing that conversion. Or you could calculate that 4 times pi is around about 12.6. Not ideal to do it that way. We can also find maximums and minimums. Pretty straightforward, this one. Menu, analyze, minimum. There we go. Again, 3.14159, of course, is pi, so it's hopefully fairly clear. that that is our pi value at a maximum. Again, our CAS calculator screen, so the calculator screen can give those exact values where needed. You could sub them in here or use solve, lots of different ways to do that. But that is a basic sketch of that first equation. Looking at our next equation, just be really careful about how you type these in. So it should be fine, but I'm going to put a multiplied sign between this -3 and sign just to make sure it's all working correctly. Same with this here. So sometimes if you have a letter or pronumeral there, it can cause issues. So just making sure it's all going to work correctly. We've set our domain. You'll also notice that I changed my t value to x, as the CAS would not understand it as a t value. So we have to use x there. And when we press enter, we get a little sketch of what we're doing there. So it looks a bit strange, this one, but if I press tab again and press 2, it gives me this horizontal line that works quite well there. We can even think about the amplitude. So it's going up and down 3 units from that point. So I could have it say 5 and -1, and we get a bit of a sense of the shape of this around those values. We could also use menu trace again to find various points of importance, or 0 to find x-intercepts. You can see that here. And again, if we wanted those as exact values, we really need to be in the calculator page. I know it's hard to manipulate things as quickly as what I'm doing here, but you just need to practice and get a little bit better at it. Once again, to change the kind of look of this, so I can actually type in here, I'm going to go -1, 5 pi on 4. I reckon that's going to be about, if I put 5 in, that's going to look pretty good. Let's go -2 here. So again, we can kind of change it around to zoom in a little bit as you like. You can actually see that it's changed the kind of how close the red line was to our middle line. In fact, they are intersecting, I believe. So let's see if we can prove that. Here we go. Yeah, so they are actually intersecting, even though it does kind of look like there's almost a gap there. But those two lines do intersect, or again, you could use trace to find that information. So this third question is an interesting one. Again, I've changed my theta in the question to x when I typed it in. I've changed my window quite a bit here, so you can see that we're going between 0 or -1 and 5 pi for my x values, -1 and 1 on the y-axis, and it actually looks like a sine graph, even though it's a cos. The reason for that is this horizontal translation. So if I do menu, where are we doing? Graph entry, equation templates, I want a line, and actually I don't need to do this. Oh yes, I do, and x equals -pi. Remember that plus pi is actually moving left a little bit, and it would be as if we moved our cos graph left pi and then went from there, and being a negative, it started at the bottom. In fact, let's go back and edit our equation. So you can double click there. Again, I'm not sure how well that works on the actual calculator, but here we go. So from there, with our negative value in front of the cos, meaning it starts at the bottom of this translation, we can actually see that that's looking pretty accurate. So I've stretched it out a little bit, but again, if I was sketching this for a test, I'd just be going from 0 to 4 pi, labeling maximums, minimums, and x-intercepts for this one. So tan graphs are certainly tricky to sketch. We can see our horizontal line of 1, that's our vertical translation there. Otherwise, our standard tan graph here between -pi and pi. We can also find those asymptotes. Our normal asymptotes are at pi on 2, 3 pi on 2, 5 pi on 2. If we divide all those values by any number in front of x, in this case 2, we're going to get pi on 4, 3 pi on 4, 5 pi on 4. So we can actually check those. We can either show them on the graph, or we can do menu, trace, graph trace. And when I type in pi on 4 here, it comes up as undefined. So we can kind of get a temporary asymptote displayed there. The process of going through and actually kind of marking that on the graph is that graph entry, equation templates, line, vertical line, pi on 4. And there we go, so we can see it there. So you can go through that process, but again, most of the time you're just getting a sense of what it looks like so that you can sketch it in a test. So if I was doing any of this CAS work in a test or an exam, you definitely want to be inserting a new problem page every time you start a new question. You'll notice here that that gives us this 2.1 instead of continuing on from our previous question. It means that anything we've defined will not cross over these pages. And I'll show you another helpful hint with that in just a moment. Let's start with this question by defining our equation. I'm going to change it to f of x because I just find it easier to operate like that, but we could use n of t. But f of x is a good idea because we can then sketch it with x as our variable. And I'm going to type it in as 1200 plus 400 times cos bracket pi is over here. Remember, we're using x now, so using that x there. And I'm just going to hit enter there. I'm not too interested in a domain just yet, so we can kind of add that later if we need to. And I'll show you why that works quite well. So to find our function, let's move on. So the period, of course, is going to be 2 pi divided by whatever is in front of x. Now that is actually pi over 3. I'm going to put that in brackets here just to make sure that the CAS knows to do this correctly, and we get a period of 6. So that's fairly straightforward. Our amplitude is just the number in front of cos, so that's simply 400. So that would be our 2 marks for that. If we're talking maximums and minimums, we really want to be going to our graph page. Because we defined our function, we can just type it straight in. You can see that bold F. So when I press enter, nothing comes up, yet it's actually there. So if I do 1600, or I'm actually going to do 1700 to have a bit of a better look at it, the reason I knew that that was the case is our amplitude is 400 and our midline is 1200. The reason I know that is our amplitude is 400 and our midline is 1200. So if I actually type in 1200 here, you can see it's splitting the middle there. And we're doing number of months, so that's where t would go up to 12. So again, if I wanted to, I can do my kind of domain here. So here we go. And there we go. That's our single year that we may be looking at. I'm just going to leave that there for the moment. So find the maximums and minimums of the population. Analyze. Well, we kind of could have done that without really working too much on this. The maximum population amounts are going to be 1600. The minimum population amounts are going to be 800. But once again, let's just prove that on our CAS. And we're getting a bit of a strange result here. To fix that, if you go to menu, settings, it's the number of digits to display. So if I change this to 5 and click OK, we can see it changes that value. So if you know scientific notation, the previous answer was exactly the same, but that just helps us display it a bit more clearly. So we're subbing 10 in for x. I'm going to go back to my calculator page, and all I have to do is do f bracket 10, just as the question states, and I would type in 1000. Over the 12 months from 1st of March 2013, find the fraction of time when the population of wombats in this location was less than n being 10. So n being 10 is 1000. So if I go back to my graph page here and type in 1000, I get this line here. I want to find the intersections between these values. So here and here, there's one, menu, analyze, intersection, this one and this one. I'm just going to see, this is the problem, is it's really hard to see. When you're doing this on a actual CAS calculator, it is a bit of a pain. There we go. And one for the road, menu, analyze, intersection, this one and this one. And there we go. So it's when x is 2, 4, 8, and 10, or sorry, t is 2, 4, 8, and 10. They are our values for this question D. So, over the 12 months, find the fraction of time when the population of wombats in this location was less than n equals 10. So finding the fraction of this time, 4 minus 2 is 2, and 10 minus 8 is 2. So for 4 months, it was below that line. 4 months of the 12 months, it was below that line. Not that we need our calculator for this, but that would of course be 1/3. So the final answer here would be 1/3. So if I was trying to maximize my marks for this question, we're talking 2 marks here, I'd be showing that I'm solving for t when our n of t equals 1000. You can see that here. We avoid CAS syntax, of course, so we don't want to write anything that we've put on our CAS. We're just explaining our understanding. Then you could add the kind of subtractions that we did. But yeah, 4 over 12 equals 1/3 would be your final mark. So it's really getting these t values and then the 1/3 as the final mark. with another extended response question here. I'll just quickly read through because understanding the actual question is important. At a chemical plant, a particular product is mixed in a large drum that forms part of a machine. To make one batch of the product, component chemicals are gradually added to the drum whilst being mixed, and then the completed product is gradually siphoned out. The process is repeated over and over. For production purposes, the drum is never completely emptied. The volume V in litres of product in the drum at time t hours after the machine is turned on is given by blah, blah, blah. So, lots of information there. We're working in hours, we're working in litres, and we've got a bit of information about how this situation is working, and it does come up through the questions. So first off, we don't need our calculator for these first few questions. What's the amplitude of this function? That is just 15, the value in front of cos. What is the period of this function? So that would be 2 pi over 4 pi over 5. Just being careful with the way that we type that in on the CAS. So I'd probably do this on the CAS anyway if I was in a test, but I would use brackets just to make sure that it's not doing, the wrong division with the wrong thing. So yeah, we're not doing 2 pi over 4 pi times 5. It gets a bit confused sometimes there. Say the maximum volume of the product in the drum. So our maximum would be the amplitude plus our vertical translation, in this case 25. So 25 plus 15 is 40 litres, and we're going to see that in the graph in just a moment. So you can see here I've defined the function on the CAS. We did change our t's to x's. That's a good start for any of these problems. And if we press the on button, we can add a graph page and of course just type that directly in. It didn't come up because our window isn't quite set correctly. You can click these numbers as you've seen previously, but what I'm going to do is show you another method, which is going to window zoom and window settings. So I'm going to set this to -1, maybe 6, because we're really just going up to 5, as you can see, as our domain that we're given for t. Our y minimum, I'll just maybe leave that as -1, just so we can see the x-axis, and I'll go 42. Doesn't really matter, just so we can see the top there. I can press tab and type in these kind of mid values and top and bottom values. There you go, so 10. So just getting a sense of the shape, that can assist us when we're sketching these functions. As was a negative cos, it did start at the bottom of our kind of top, middle, and bottom lines. So that does help us sketch. And then really just working out these values, you can see that I kind of mark them along the bottom there. If I was doing this, I'd be finding all my kind of maximums and minimums and everything, just using the CAS as we've seen previously. There's no x-intercepts. We can find endpoints by using trace, and the other one was at 5. There you go. So that's our sketch through there, finding all of those values. We can see there's symmetry occurring as well. So the midpoint between 2.5 and 0 is 1.25. We can find that on our CAS here, but we could have calculated that without the use of our CAS. So what is the average volume of the product present in the drum? So if we're cutting off at this point of 5 hours, and we're looking at the average volume, it is above our midline for the same amount of time as it is below the midline, meaning that the average is simply going to be 25 litres. During the production of one batch of the product, for how long is the volume of the mixture in the drum increasing? So that's a really interesting question. So this is where the volume is increasing between 0 and 1.25, then decreases to 2.5, and that is one full cycle of creating a batch. For how many hours would the machine need to run if 3 batches of the product were to be produced? So again, it takes 2.5 hours to run one batch. So 3 times 2.5 gives us 7.5 hours. It doesn't give us it does say in hours, so we just leave it at 7.5 hours, but we're going to get a minutes question soon, so be careful with that. On a particular day, the machine was turned on at 7 a.m. and turned off at 5 p.m. So 7 a.m. is when t is 0. That would be a total of 10 hours, 7 to 5. So on this day, how many batches were produced? If it takes 2.5 hours to make one batch, then we can do 10 divided by 2.5, meaning 4 batches. On this day, what was the volume of the product present in the drum? At 11:30 a.m., express your answer in litres correct to 1 decimal place. So here 11:30 a.m. would be the same as 4.5 hours. That's from 7 a.m. to 11:30 a.m., 4.5 hours. My 2 marks are coming from showing that I understand that t equals 4.5. You can see that here. And then the final solution to 1 decimal place of 20.4 litres. Once again, if I go back to my calculator page, all I have to do is type in that 4.5 and I get 20.36, and I just rounded correctly there. On this day, how many minutes did it take for the volume of the product in the drum to reach 32.5 litres? So here I'm going to do a solve f of x. Remember, we're not using t in this instance. F of x equals 32.5 comma x, and it's going to give us some strange answers, and that's because of those general solutions. So maybe what we can do is set that domain where let's go for 0 to 10, which is what we're looking at here. And we get some difficult values because we're working with decimals. We could get exact there by doing 32.5. So plus 1 over 2. Let's see if that gives us, yep, so that gives us our exact values. So it's actually at that height a lot of the time, or that value of litres a lot of the time. But the first instance of that is when we have 5 over 6, but it wants it in minutes. So I'm converting that to 50 minutes. Once again, showing what I've done in the CAS, but without using CAS syntax, is 1 mark, and then 50 minutes is our final mark. So converting that value, or understanding that we need to convert from there.